Hello everyone, welcome to the Solidity Fundamentals course. I'm Anjali and I'll be your guide for this course. So today's video is a continuation of a previous video in which we discussed the different value type data types present in the Solidity language. We had discussed signed integers, unsigned integers and booleans in our last video, and today we are going to discuss about the address data type, the enumeration data type and the bytes data type. So let's begin with the address data type. The address data type is declared using the address keyword. And as the name suggests, it is used to store Ethereum addresses. So this address data type is also a very unique data type which is specific to the Solidity language, and it is used to store all the addresses in the variables. So in case you want to store an externally owned account, a wallet address, or you want to store the address of a smart contract, different smart contract as well. So any kind of Ethereum address, if you want to store, you can use this data type. Again, address data type is of two possible values. So two subtypes are possible for this address data type, which is the address itself and address payable. So what is the difference between the two? Address payable is used to signify those variables in which the movement of cryptocurrency is involved, meaning in those cases where you want to send money to send cryptocurrency to a particular address, there you have to mention that address as address payable. Only then are you allowed to send the send equivalent or transfer even the ethers to that address. So if you just want to save the address for other purposes and transferring or sending of ethers is not required, then you can simply use the address keyword. But in case the message dot value is not zero for you, as we've discussed the message dot value part in our last video also, so in case message dot value is not zero for you, that means you are sending some crypto along with the transaction, then your address keyword which you're using has to be accompanied with the payable keyword. So the default value for the address data type would be 0x and a lot of zeros accompanied with it. Actually, the size of a address data type is 20 bytes. So the default value is actually 20 bytes, all zeros, but beginning with 0x. So that is the default value of an address data type. So since you know that all the Ethereum addresses, they are of 20 byte size. So naturally, the size of this data type becomes 20 bytes. So any variable which has the address data type, it will take 20 bytes of space and it will be used to store any kind of Ethereum address. But in case you want to use the address for transferring of crypto or sending the crypto, then you need to use the payable keyword along with the address keyword. Moving on to our next data type, which is the enumeration. So we will be having a separate video discussing the whole enumeration in detail, all the implementation part. But for now, just let's have a quick overview of what it is. Actually, enumeration is a user defined data type. It is a value data type. That means always whenever it is used, a reference is not used for enumeration. The exact values are used. So copies of the values are used basically. So, but it is not like the other data types, it's a user defined data type. So it is declared using the enum keyword. And what is the utility of enum as a data type? It is used to store constant values, and it is used to limit a variable to a few predefined values. So let me explain this by an example. So just supposedly you are making a decentralized application and you want to allot a lot of roles to the users. So now, for better clarity of your code, you want to have roles like admin role or developer role or technical writer, all those kind of roles. But obviously, at the back at the smart contract level, you cannot define it in strings. I mean, that is always, so it is very, one is it is very time consuming if you type all the roles like this, and the other is that it is error prone, right? But in case you want to make it less error prone, bug free, then you would what you would want, you will keep IDs for all of them. So you will say that role ID 0 means admin role, role ID 1 means developer role, so you will decide it somewhere, right? So you, that's a better way of approaching at things, that you know you have replaced those lengthy words using those key integers, so that there's no problem, there's no error in while writing the code. But then that makes your code very non-readable kinds, not very user friendly. So here is when enum comes to your help. So using that user defined enum, you can define the roles and you can allot values starting from 0. So obviously you can change the starting value, but by default it starts from 0. So by starting from 0, you can allot constant values to those words which you choose, and in the whole program you can use those keywords to reference the integers. Okay, so it enhances the readability of the code. And as I told you that the first uh, part of that enum, so it will contain a list of a lot of variables, and the first variable will hold the value 0 by default. You can change this if you want, but by default it will hold 0. So enums we are going to discuss in a separate video in detail, so that we are able to understand how to define these enums and how can we use them. So for now, you just know that it is a user defined data type. So now let's discuss the last value type data type, which is the bytes. So bytes represent fixed sized byte arrays, and they are used to store information in binary format. So we know that sometimes while programming we need to save information in just in binary formats. We do not want to store information in complete sentences, so we need binary format. So for that, this data type has been made available to us. But again, Solidity has its own feature of giving you a lot of variety in data types itself. So as we have seen that in signed and unsigned integers also we had a lot of variations. So in similar case, bytes also has a range from byte 1 to byte 32. So here there is no question of 8 step of 8. So byte 1, byte 2, byte 3, byte 4 up to byte 32 is available to you in the in form of different data types, and you can pick any depending upon the size of the data which you want to store. So for clarity, byte 1 will give you, as the name suggests, one byte of storage. So 8 bits of storage will be provided to you by byte 1. But if you need to store data which requires more than 8 bits, then you can go for byte 2, byte 3, and the maximum is byte 32. So now this comes under the category of fixed sized byte arrays. And so we are going to discuss bytes and their implementation in detail when we are going to discuss arrays for our course. So today we are not going to see the implementation part, just an overview, so that things don't get a lot confusing for you. So just understand that bytes basically is used to represent binary format information in fixed size arrays, and that size can be chosen by you from a list of byte 1 to byte 32. And as it is mentioned that the default value for byte, in case you do not give any value to bytes, it will pick 0x00 as its default value. So this is the default value provided by Solidity for all the byte data types. So this is a remix IDE, and now we will be practically viewing all the data types which we have learned. So let's begin by using the I think we studied the signed integer first. So let's start by using the signed integer. So for that, as we know that we use a int keyword for a signed integer. Let me make it public so that we are able to view it, and let me give the name as my uh, signed integer, my signed int, and let me give a value. So let me give a negative value to it, right? And let's save this and compile it. So as you can see, the green tick means that it has compiled successfully. So here I just want to explain you that range part. So in case, so for this I need to just reduce the size. So if I mention int 8 over here, this would mean that my range is limited now to what? Minus 128 to plus 127. So imagine if now I just put 128 over here. So now this becomes out of range. So now the moment I try to compile it, it gives me an error. And as you can see here, the red error, it shows that the literal is too large to fit in int 8. So that means if I specify 8 bits along with signed integer, so there becomes a fixed range which is minus 127 to 128, minus 128 to 127. And since 128 is not in the range, so it is giving me the error. So in case I make from 8, I can go to steps of 8. So if I make it int 16 and then I try to compile it, now the program gets compiled successfully. So that is the whole concept of range. So the formula is very simple. We've discussed it in the last video also. So for now, you just see that. This is the way we can save signed integers. So let me put a minus sign over here, and let me give this value as 120. Okay. So this is a signed integer. Now let's discuss the unsigned integer. For that unsigned integer, you always have to use uint. So that is a practice. As Solidity programmers, you need maximum times you use this unsigned integers, because for all the token IDs, etc., it's always unsigned. So you do not have to write int, you have to write uint. Again, I say my unsigned integer, and I give the value to this as 23. So it's a simple value, and if you compile it, it will be compiled. Again, the range part is the same. I don't want to repeat it, but if you, in case you will choose uint 8 here and you will put a bigger value, it will not be compiled and it will show you an error. Next is a boolean. So let me use a bool word, public, and maybe I say that flag. So by default, we are not setting any value. We'll see that what is the default value set by the Solidity. We know it should be false, right? And finally, we have learned about the address data type as well. So we have address as a data type, and I name it as public, and I say my address, and the value I save here is message dot sender. So you remember we've discussed the global variables, and message dot sender is the account address which has deployed this contract. So that should be stored in my address. So that's it for now. Let's compile the code. It's compiled successfully. Let's deploy it. So I've deployed the code. Let me check the instances for this. So first of all, let's see this my signed integer. As you can see, the value is minus 120, same as here. Then my unsigned integer, the value is 23 as we have declared over here. Now for flag, we haven't set any value. So if you click on flag, you see a false value has been returned. So that is what we were expecting, right? So now let's click on my address. So the moment I click on my address, this address 0x5b38 is returned. Now let me go to the top and let me see the account. See 0x5b3. So this was the account which was used to deploy this contract, and it is the my address is showing the same address. So message.sender has been set, right? So that is how address keyword is used. This address data type is used. So this is the implementation of all the data types. The other data types we are going to discuss in detail separately in separate videos. So see you in the next class.